Yo, what's up guys? So this is my completed CPU. So this one is not color coded because I'm lazy and this might just look like a bunch of redstone blocks thrown together. But let's break down the parts of the CPU and how everything is connected. So I already made a video kind of breaking down this computer, but now that you guys can kind of see it in Minecraft, I want to just kind of break it down one more time, just briefly. We have our first part here. I'm going to draw it in red. Bad square, rectangle. And this is our RAM, which is just our major memory unit for the CPU. And right now I'm just using 128 bytes. I can always expand it later, but 128 works for now. My next section is the ALU. The ALU does math for the computer, basically, arithmetic and logic unit, and exactly like its name, it does arithmetic operations, subtraction, addition. It also does logical operations, so like and, or, not, XOR, all that stuff. And what I've added here is it also can do conditional functions, so it can do greater than, less than, equal to, not equal to. This kind of long contraption over here is my program memory. And so this differs from RAM because it's ROM, which means it's hard coded in. But this program memory just contains the program, basically. It's the binary numbers that tell the CPU what to do. And finally, the last major part, I think I talked about in my video, is the registers. And these are general purpose registers. I only have 4 of these. And these contain the data, the values that I am immediately working with. These are kind of the fundamental parts of my CPU I talked about in my video. And one thing I briefly went over was the control unit. And this is kind of, it decodes the program memory and kind of tells the computer what to do. So it kind of has 2. The first one here is for the major one. It decodes the function, so the 4 binary bits that tell the function. It decodes that and sends out a bunch of different signals depending on the function. And it tells the CPU where to send all the different data values from the program memory. Now this other control unit is for setting and enabling registers. Basically just controls all the different registers. And it takes these data values that this first control unit moves around, and it decodes them into specific registers. And as you can see here, there's all these wires coming out. So it is connected to basically every part of the CPU. And so it, like I said, decodes the data values into registers and either sets or enables those registers. Alright, so I accidentally deleted all my drawing, so we're just going to have to pretend it's all there still. But what I want to look at next are the external functions. So right here we have our output, and here we have our input. So our input is very simple. It just has a little latch that I can input a number here, and then whenever I want to actually input it, I unlock the latch and it just loads a number. And so right now I just have one port, so I can really only connect up one device to it. But I don't really have anything to input right now. I don't really have any plans to connect it up to anything right now. So I'm just going to leave it as a manual input. Now my output here, there are 1, 2, 3, 4 different output ports. So I can choose which port I want to output to. So I can have at most 4 different devices or peripherals hooked up to it. So I do plan on attaching it to some external devices soon, so stay tuned for that. But yeah, so that's just my input and output, so those are my external functions. So earlier I said that these registers right here are my general purpose registers. But what are some, I guess, specific purpose registers within my CPU? So the first one is the accumulator, which I talked about a lot last video. The accumulator is really just the output of the ALU. And it's beneficial because it is a placeholder between the output of the ALU and literally the rest of the CPU. So the accumulator is beneficial because I can basically just have another register to hold my data. It also allows me to move the output to any part of the CPU. It allows me to manipulate it. And finally, it allows me to perform jump if operations very quickly, and I'll show you how that works in a little bit. The next one, the next register that I want to look at is you can't really see it, but it's the memory address register. The memory address register, again, I talked about all these last video. The memory address register basically just holds what memory cell you're accessing in the RAM, and it's beneficial because it can allow you to almost treat the RAM as if it's another register. So you can load the value that you want to access from RAM to the memory address register, and then instead of saying, read or write to, the 75th register, you can just say read or write to RAM because the register is already selected. So that really simplifies the instruction process and allows me to save a lot of bits, especially when I increase the memory, the RAM size. Now, the last one that I want to talk about is, you can't really see it, but it's under the control unit, and it's the instruction address register. And the instruction address register basically just keeps track of what step you're on. And so it's kind of a 2-in-1. It's an adder and a register in one. So I can send one signal to it, and it will increase by 1, just going to the next step. I can send another signal to it, and it will allow me to input whatever number I want. So this allows me to create a jump, so skip to another step in the computer, which is, one of the most important functions a computer can do. But now that we have completed this, let's take a look at the actual CPU. So now that we have looked at that, let's take a closer look at my CPU. So my program memory outputs 16 bits at a time. 8 of those bits go up here, and so it goes either directly into the computer or into the second control unit over here, which I'll talk about in a bit. These very bottom 4 bits are variable, so they could be either a output port or an enable or a set. And then these 4 are the most important. These are the function, and so these go into a decoder, which then turns a binary number into a single line. So if it's a 1, it would go to move, or if it's a 3, it would go to jump if. And so whenever one of these are selected, whenever it decodes it, the correlating line will turn off, and these torches will turn on. And so these torches will send a signal through one of these lines, and I have labeled all these lines so I can, not confuse myself. So the first one that we'll look at is, let's just look at the load. It's the easiest. So this load goes back here and goes into, it unlocks this line here, which allows basically just these 8 bits to go through into the rest of the computer. And then let's look at set and enable. So this second CPU over here takes the top 4 bits goes to the set section, and the bottom 4 bits of the first byte goes to the enable. So it unlocks, because right now it's locked with this torch, so it's locking all of these outputs, all these signals, and so whenever I have those set or enable lines turned on, it will unlock these, and it allows me to turn a function to set, so to memorize a number, and also to display the value of a function. So that's pretty simple, just memorizing and displaying. And then there are load set and load enable, which sound a little weird, but it's really just these bottom 4 bits. Like I said, these bottom 4 bits are variable, so if I want them to be a set, I will move those bottom 4 bits up here and through here. And if I want to have those bits be enabling a register, they'd bring them around here and into here. So that gets most of the functions out of the way. So the increment step is fairly simple. It's just because my computer doesn't really have a clock. What it does is immediately as it gets the instruction, it sends a signal to the increase step, and it just goes to the next step. That's really it. Some do not have this. For example, the jump if, which instead sends a wire through this jump if signal. Now this jump if signal actually is really, really simple. This wire here is always pulling from the accumulator, the very first bit of the accumulator. If it is off, the signal's inverted here and sends a signal, and it just increases it by 1, just does nothing. But if it's on, that means it's true, then it will input a step, so that causes the jump to another step. So if it's true, it jumps. Now let's see, the output register, that just unlocks the output. And then cutoff is probably the weirdest one, where it actually cuts off this output here. So instead of, or it takes whatever step it is and turns it to 0. And this is because I was running into an issue where it would switch steps so quickly that these 4 bits, if it was a move function back to back, these 4 bits wouldn't actually change. So it wouldn't send another increment signal. So what would happen is it would just get stuck on that step. So I have a cutoff, which basically just sets everything to 0, because my 0th instruction actually is nothing. And why I do this is that it has a placeholder step, so when it's easy because I can just set it to 0 and it will pause everything. I can also use that as like a halt, so because the 0 is a guaranteed nothing, I can always jump to 0, and that's kind of my exit function for my program. But it basically just sets to 0, which turns off all the bits and allows the decoder to reset. So that was kind of a in-person rundown of how this CPU works. I have a Fibonacci sequence that I want to show off next video, so stay tuned for that. But for now, that's about it. Peace.